Extrasolar planets, or exoplanets, orbit stars other than our own, each with its own unique history and set of mysteries. From frozen giants encased in eternal ice to gas giants with atmospheres hotter than stars, these faraway worlds provide a window into the astonishing variety of planets in our solar system. Exoplanets like WASP-12b, which is about 1,400 light-years away from Earth and is slowly perishing, captivate our interest not because it could support life, but because of the dramatic and tragic nature of its existence. As we travel through space, we will learn more about these planets and the profound mysteries surrounding them. WASP-12b is a gas giant that orbits very close to its star, which exposes it to extreme radiation. Its destruction is not an explosive event, but a drawn-out process, similar to how life's demise can be gradual and inevitable. The planet is sealed in its fate due to its proximity to its parent star, a yellow dwarf, which puts it in the path of an intense gravitational pull. The surface of WASP-12b reaches temperatures of over 2,500 degrees Celsius, and the planet's atmosphere is being stripped away by the intense gravity of the star. As a result, the planet will eventually disintegrate, leaving behind only a trail of gas and dust that spirals back into the star. This gradual but inevitable destruction raises deep questions about the nature of existence. WASP-12b is a cosmic symbol of. The planet's demise stands in sharp contrast to the conception of creation and growth that frequently predominates in our understanding of the universe. Rather than a world blooming and expanding, we witness its unraveling, a process that compels us to face the truth that everything, no matter how grand or apparently eternal, is subject to decay. WASP-12b's gradual disintegration can be viewed as a metaphor for the human experience, similar to how the planet is. Destruction is often a slow, gradual process that unfolds over time, shaped and undone by forces beyond our control. Just as time shapes and undoes us, it is also a constant presence throughout our lives. We are born, we grow, we live, and finally, we must face our own demise. The idea that our existence is fleeting is not new, but WASP-12 provides a striking, almost poetic illustration of this truth. The destruction of WASP-12b is not the end of the world, but rather a transition to a new form of existence. This concept of destruction leading to transformation has profound philosophical implications. It implies that even in the face of catastrophic events, the material that once comprised the planet will eventually be absorbed into the star, becoming part of it and fueling its energy. In the face of complete annihilation, there is always the chance of something new and different rising from the ashes. A similar pattern exists in human life, with periods of loss and decay followed by periods of renewal and the emergence of something new. This serves as a reminder that destruction is not the polar opposite of creation, but rather an integral part of the continuous process of change and evolution. The fate of the wasps and bees further emphasizes the precariousness of existence. Earth, once a massive gas giant, is now being torn apart by the star that gave it life. This fragility is something we can all relate to. Our lives, like the planet, are fragile and influenced by forces beyond our control. We are shaped by the people and circumstances around us, just like WASP-12b is by its star's gravitational pull. Rather than being afraid of change, we should embrace it, something to be recognized and welcomed. It serves as a gentle reminder that life is precious and that every moment is short and should be treasured. Just as WASP-12b is being gradually ripped apart, so too are our lives progressing through their stages, with each passing second bringing us one step closer to our own unavoidable demise. Yet, amidst this precariousness, there is also beauty, the beauty of being alive and experiencing life in all its facets. As it slips away, the fate of WASP-12b also prompts us to reflect on the nature of endings. The destruction of the planet is not a sudden event, but a gradual process that stretches out over time. Rather than a single moment, each passing second brings it closer to its final dissolution. This forces us to reevaluate our perception of endings, viewing them as transitions rather than abrupt conclusions. Instead, we should see them as parts of a larger process of change. Enigma GJ 1214b and the search for a water world GJ 1214b is a planet shrouded in mystery, located about 48 light-years from Earth in the constellation of Fucus. This world has captured the imagination of many, but its tale of transformation ultimately mirrors that of the universe. The universe is in a perpetual state of flux, changing around every particle in it. Since its discovery in 2009, GJ 1214b has fascinated scientists and astronomers. It is classified as a super-Earth, meaning it is larger than Earth, but smaller than gas giants like Neptune and Uranus. What makes GJ 1214b even more intriguing is its thick and mysterious atmosphere, which has sparked numerous theories and debates regarding what lies beneath its clouds. Another mystery that GJ 1214b has presented is that it orbits a red dwarf. There's a lot of speculation about the nature of this distant world known as GJ 1214b. One of the most compelling theories is that it could be a water world, a planet covered entirely by water, because the atmosphere is dense and opaque, making it nearly impossible to observe the planet's surface directly. The star is much smaller and cooler than our sun, and it's far enough away to be in what could be a habitable zone, depending on the specifics of its atmosphere. The planet's low density leads scientists to believe that water and other light materials make up the majority of GPJ 1214b, rather than rock or metal. If this is the case, the world could be completely different from Earth, with water playing an integral role in both the landscape and the atmosphere. The prospect of a water world brings up intriguing questions about the possibility of life on Earth, as water is essential for all forms of life. For the time being, at least, the mysteries surrounding the atmosphere of GJ 1214b are being further exacerbated by scientists' ongoing examination of the planet through its early observations with the help of the Hubble Space Telescope. If GJ 1214b does, in fact, have a large ocean covering it, then it is possible that it harbors life in its deep, dark waters, protected from the harsh space conditions by the planet's thick atmosphere. Some models propose that the atmosphere could be dominated by clouds of high-altitude steam, while others have suggested that it might be composed of more exotic materials like hydrogen or methane. If the atmosphere is indeed rich in water vapor, then each of these possibilities would have profound implications for what lies beneath the clouds. However, the exact composition of the atmosphere is still unclear. The planet GJ 1214b could be a hot, steamy world with a thick ocean of water vapor in its atmosphere, if hydrogen is the dominant gas. On the other hand, if methane is the main component, then GJ 1214b could be a distant, icy relative of the gas giants in our solar system, or something completely different altogether if hydrogen is the dominant gas. Unfortunately, the data we have does not yet allow us to draw any firm conclusions. Cannot confirm or disprove any of these theories with certainty due to the dense clouds surrounding GJ 1214b, which has prevented scientists from peering into the planet's interior. Instead, they have had to rely on indirect measurements, such as the way the atmosphere absorbs and scatters light from the star, to fill in the gaps in our understanding. This has forced astronomers to engage in a kind of scientific detective work, requiring patience, creativity, and acceptance of mystery, as new findings seem to provide more questions than answers. One fascinating thing about GJ 1214b is the chance that its atmosphere hides something completely unexpected. Planets like GJ 1214b, which are either mini-Neptunes or super-Earths, are common in the galaxy, but we know very little about them. This means that GJ 1214b could hold secrets that challenge our theories about how planets form and evolve, like the planet GJ 1214b has sparked a plethora of wild speculation regarding what may be going on beneath its clouds. Some scientists have proposed the existence of a thick supercritical water layer, a state of matter where the planet's extremely high pressures and temperatures have transformed layers of ice or rock. On the other hand, the atmosphere could be concealing chemical processes that have never been seen on such a grand scale. There is a fluid form of water that is neither liquid nor gas, but something in between. In this case, the surface of GJ 1214b could be an alien world where the line between the sky and the sea becomes a thick mist. Another theory implies that GJ 1214b could actually be covered in a huge ocean of liquid ammonia or another exotic chemical instead of water. In this case, the environment would be physically and chemically very different from what we know on Earth. Despite years of study, GJ 1214b remains one of the most perplexing exoplanets we have discovered. Every new observation brings us closer to understanding the planet, but the possibility that it is drastically different from any life forms we are familiar with, possibly based on entirely different biochemistry, adds another layer of intrigue to the planet. This forces us to reconsider the limits of life and the types of environments where it might thrive. The search for answers about GJ 1214b is ongoing. Scientists continue to refine their models and develop new techniques for probing the planet's atmosphere. Future telescopes like the James Webb Space Telescope hold the promise of providing more detailed observations that could finally reveal, but they also reveal new complexities that challenge our assumptions. It's a reminder that the universe is full of surprises. GJ 1214b is a distant, cloud-covered world that continues to fascinate and perplex us. It stands as a testament to the mysteries beyond our solar system, challenging us to think beyond what we know, explore new possibilities, and embrace the unknown. In the end, the search for answers about GJ 1214b is about more than just understanding one distant planet. It's about unraveling the puzzle of this mysterious world. The mystery of GJ 1214b serves as a reminder that our universe is enormous and teeming with wonders. There is, and always will be, much to learn, explore, and uncover. The TRAPPIST-1 star system, which lies approximately 40 light-years from Earth in the constellation Aquarius, has been the focus of much interest among both scientists and the general public as a result of its remarkable discovery. Unlike any other star system we've seen so far, TRAPPIST-1 is home to a family of 7 Earth-sized planets that circle around a single dwarf star. The planets are densely packed around the star, with orbits that are significantly smaller than our own solar system. Interestingly, some of the planets in this system actually lie in the habitable zone, a potential area where liquid water could exist. The sizes and densities of the planets in the TRAPPIST-1 system vary greatly. Some look rocky, like Earth, while others may have oceans or thick atmospheres. What really sets these planets apart, though, is the possibility that they could be home to life. The scientific community is incredibly excited about the prospect of discovering so many Earth-sized worlds in such a system, particularly ones that could have the ideal conditions for life. What's more, the planets in this system have such close orbits that if you were to stand atop one of these planetary bodies, you could see your neighboring planets clearly in the sky and maybe even make out some of their features. The interplay between their gravitational pulls is fascinating, too, since it causes the planets' orbits to twirl and turn in a complex cosmic dance. Thanks to this dance, scientists have been able to measure the masses of these planetary bodies with remarkable precision, shedding light on their possible compositions and atmospheres. As our knowledge of the cosmos and our place in it grows, we are compelled to expand our horizons beyond our solar system and contemplate the likelihood of life in other, more distant, potentially habitable world systems. The discovery of 7 such planets in a single star system raises the intriguing prospect that life may be abundant in the galaxy. Now picture if every one of these. The 7 planets in our solar system each supported distinct ecosystems, molded by their specific environments. One of these planets, 1b, was so close to the star that it could be an extreme world with a barren rocky landscape, rivers of molten rock, and an atmosphere thick with vaporized minerals. Any life that could have survived on this planet would have to be extremely hardy, perhaps finding refuge underground from the intense heat or in the shadowed craters where temperatures were more bearable. It's possible that further out in the universe, on TRAPPIST-1e, temperatures are just right for liquid water to exist on the surface. This planet could look a lot like Earth, complete with oceans, continents, and a breathable atmosphere. But instead of light, it could have alien trees whose leaves have adapted to the dim red light of the TRAPPIST-1 star. The seas could be teeming with all kinds of life, from tiny organisms to gigantic, complicated creatures that have evolved to survive the long day. In the year 1F, just a little further from the star, there might be a planet entirely submerged in water. On this watery world, life may have originated deep below the surface, away from the star's radiation, in an eternally dark environment. Maybe gigantic bioluminescent creatures swim through this water, using light for both vision and communication. Underneath the water, there might be hydrothermal vents that provide the heat and nutrients necessary to sustain life. Extending our gaze outward, we can see that TRAPPIST-1g may be an icy world with a surface frozen in eternal winter. However, beneath this frozen surface, there may be a huge subsurface ocean that is heated by tidal forces and kept liquid by the gravitational pull of the star. Life on this hidden ocean may take a different form than on TRAPPIST-1f, perhaps flourishing around hydrothermal vents. These creatures may have adapted to a colder, darker climate. The outermost planet, 1H, is probably a frigid, icy world far from its star. Its atmosphere is probably thin and its surface is barren, much like Mars. However, what if this planet had its own kind of life that adapted to the cold and low gravity? Maybe the surface is covered in strange, hardy plants that absorb and store the faint warmth from the star. In this case, life would have to be extremely efficient, preserving every bit of energy and water it could. The idea that each of the planets in the TRAPPIST constellation could support its own unique ecosystem is more than just a theory. It's a reflection of the vast variety of life on our planet, where creatures have adapted to live in the most hostile climates imaginable, from the hottest deserts to the coldest polar regions, from the top of the world to the bottom of the ocean. Given this incredible diversity, it's not far-fetched to think that life could also exist on the planets in the TRAPPIST constellation. There's a remarkable amount of diversity that could exist within a single star system, which is what makes this speculation so intriguing. For example, our solar system only has one habitable zone planet, but there are 3 or 4 in the TRAPPIST system, each with the potential to support ecosystems as diverse and complex as Earth's. Each of these planets could symbolize a distinct chapter in the story of life in the universe, with its own lessons and unique viewpoints on what it means to be. Kepler-16b and its 2 suns are an exoplanet situated around 200 light-years from Earth. This irregular orbital pattern defies the usual rhythm of our solar system and forces us to think beyond our own experiences and into the realm of alien ecosystems formed by forces we can hardly fathom. The 7 planets in the TRAPPIST-1 system encourage us to broaden our comprehension of the universe's potential forms of life. Circumbinary planet, so called because of its unusual relationship with 2 stars, the stars Kepler-16a and Kepler-16b, which have been in a perpetual gravitational embrace for billions of years. Kepler-16b, a gas and rock giant, moves in a steady, nearly circular orbit around this binary system, balancing the gravitational fields of its 2 suns, an impressive feat of naturalism. The engineering of Kepler-16b has enchanted astronomers and dreamers for a long time. The concept of duality is key to grasping the meaning of this faraway world, which represents the universe's yin and yang in many ways. Kepler-16b has 2 suns, one of which is a large, hot star, and the other a smaller, cooler red dwarf. Despite their differences, they cooperate, their gravitational forces creating a stable environment in which Kepler-16b can thrive. The planetary system in question serves as a reminder that harmony doesn't necessarily mean uniformity. Sometimes, it's the interaction of opposites that produces the most lasting equilibrium. As Kepler-16b travels around its suns, it encounters a reality very different from our own. Picture yourself on Earth, where the sky is illuminated by not one, but two brilliant suns, each casting its own shadow on the Earth. At different times of day, the suns may rise and set in a kaleidoscope pattern, creating a kaleidoscope effect. In this multi-hued universe, the stars spin in a never-ending tango of light and dark, casting a familiar yet strange shadow across the land. The duality of Kepler-16b suns provides a profound metaphor for the complexity of life. Just as Earth must balance the gravitational pull of two stars, so too must each of us navigate the opposing forces that shape our own existence. Positivity and negativity, joy and sadness, love and loss. Kepler-16b and its twin suns are a cosmic reminder that balance isn't about picking one extreme over the other, but about discovering a happy medium where the two can live in harmony. As we contemplate the mysteries of this star, we can't help but wonder what stories ancient civilizations might have told under its benevolent gaze. What myths might have emerged from the sight of two suns rising and setting at the same time? Alternatively, looking at the twin suns through the prism of the eternal twilight, they could have perceived them as divine twins symbolizing the creation and destruction sides of a single God, respectively, or as lovers forever chasing each other across the sky, their dance representing eternal passion and relentless pursuit. In this world with two suns, the concept of time could have taken on new meaning, with days and nights being dictated not by the sun, but by the eternal ebb and flow of the universe. Imagine a world where festivals were held during times of great power and possibility, when the suns were in the sky together, or during the rare occurrences of one sun eclipsing the other, a moment of profound mystery and transformation. The sky, illuminated by these two guiding lights, would have been a canvas for endless imagination, inspiring wonder and wonder for generations. Perhaps the inhabitants of this world developed a philosophy based on this idea. Their world, like the sun's, was held in balance by the gravitational forces of two stars. They may have viewed their two suns as a reflection of the dualities that govern their own lives, and they may have interpreted the dance of the suns as a cosmic lesson in the importance of finding harmony amidst the push and pull of opposing forces. They may have also believed that the forces of good and evil, love and hate, joy and sorrow, comprise their own lives. 55 Canary E, a super-Earth considerably larger and more massive than our own planet, orbits extremely close to its parent star, completing a full revolution in just 18 hours. Because of its close orbit, 55 Canary E experiences temperatures that scientists and the general public find hard to believe, and the planet's proximity to its star only adds to the awe. 55 Canary E is located 40 light-years away in the constellation Cancer. 55 Conra E is fascinating not because of its extreme heat, over 2,400 degrees Celsius, or its closeness to its star, but because of its composition. The planet's unusual density and the star's higher carbon-to-oxygen ratio than our Sun have led scientists to speculate that 55 Conra E may have formed in a carbon-rich environment, which would explain the planet's apparent abundance of diamonds. 55 Canary is a planet where the bedrock is made of diamonds, a name that captures the imagination and conjures images of a world shimmering with vast, unbroken expanses of diamonds shining under the light of its nearby star. The idea that an entire planet could be composed of diamonds challenges our current understanding of the planet's formation and composition of diamonds. Diamonds, which are formed deep within the Earth's mantle under intense pressure and heat and then brought to the surface through volcanic eruptions, are symbols of wealth, rarity, and beauty. The process is rare, and the resulting diamonds are priceless for their brilliance and hardness. However, on 55 Canary E, if the diamond planet theory is true, diamonds might be as common as rocks are. Diamonds are valuable because they are rare, difficult to obtain, and beautiful, but in a universe full of unimaginable wonders, what does it mean for something to be precious if diamonds were as common as dirt? Would they still be valuable in such a world where they make up a significant portion of the planet's structure? 55 Canry, compels us to ponder these questions, which test our notions of wealth and rarity. It implies that our valuation of things is not a fixed, absolute metric, but rather profoundly contextual, influenced by our surroundings and life circumstances. For example, diamonds are rare and valuable due to the conditions that produce them and the effort needed to cut and polish them. Extract them, but on 55 Cry, those same conditions might be commonplace, making diamonds just another part of the planet's geology. This shift in perspective makes us think about how we value things in the universe. The more we learn about the cosmos, the more we realize that what we think is extraordinary might be ordinary on a cosmic scale. There are planets made of diamond stars burning with unimaginable heat and galaxies filled with billions of stars. In a universe so vast and diverse, how do we decide what is worth our time, is genuinely valuable? Maybe the secret is in how we perceive these marvels. A diamond, for example, could be nothing more than a common rock on 55 degrees. But on Earth it represents beauty and rarity. Due to the tale, it tells of the relentless heat and pressure that have persisted over eons and the forces of nature that have shaped our world. Similarly, the significance we give to anything, a diamond or a faraway planet, depends on the stories we tell about it, the lessons it teaches us, and the ways it motivates us. Diamond Planet also poses questions. In our earthly quest for wealth, we have often exploited natural resources like diamonds, oil, and gold without thinking about the long-term effects of our actions. However, in a universe where planets like 55 Canry could exist, with entire worlds composed of diamonds, how can we balance our earthly desires with the enormity of the universe? This perspective challenges us to look beyond material wealth and consider. The discovery of a planet like 55 Canry could ultimately help us understand the true meaning of wealth, which is not measured by material possessions, but by the experiences and insights that enrich our lives. In a universe full of wonders, what matters most is not having as much material wealth as we often think. Rather, it's about having connections, knowledge, and wisdom. Discovered in 2006, Trace 2b is an exoplanet that defies our expectations of what a planet beyond Earth should be like. It orbits a star in the constellation Draco, about 750 light-years away. What makes Trace 2b unique among the planets we've found is its incredible darkness. Among the darkest exoplanets, it reflects less than 1% of the light that hits it. In a cosmos full of glowing stars and planets, Trace 2b stands out as an anomaly. Trace 2b is a gas giant that appears to absorb nearly all light, leaving it shrouded in nearly total darkness. It is comparable in size and composition to Jupiter, but that's about it. Jupiter, with its whirling clouds and bright bands, is a planet that reflects a significant amount of sunlight. In contrast, Trace 2b is so dark that when viewed from space, it can barely be distinguished from its star. Trace 2b's utter blackness has been likened to the look of charcoal or black acrylic paint on Earth. The planet doesn't radiate light, doesn't sparkle, and lurks in the shadows, taking what it can get while giving nothing in return. But Trace 2b's darkness is more than just a physical trait. It stirs up strong emotions that are difficult to ignore. Something unnerving about a planet so utterly black, a world that appears to defy the natural order of things in A. In a cosmos where light is typically associated with life, warmth, and energy, Trace 2b stands in sharp contrast. It is a planet where light goes to die, embodying the unknown and the fears that come with exploring uncharted territory. Experts still don't fully understand why Trace 2b is so dark, adding to the air of mystery and unease around it. One possible explanation is that its atmosphere contains chemicals that absorb light instead. It's more likely that the planet's atmosphere contains substances that absorb light at specific wavelengths than that it reflects it. The planet's extreme heat, which reaches temperatures of over 1,000 C, also makes it unlikely that clouds would form to reflect the light, so the atmosphere is free to absorb it without scattering it. The result is a world that is not only dark but also hot, hostile, and uninviting. Trace 2b's atmosphere is possibly a whirlwind of gases and particles that trap heat, making for a sweltering, suffocating atmosphere. This planet appears to shun life. Its extreme conditions test our notions of what a planet can be. And Trace 2b is more than just black. It has an eerie, otherworldly quality that compels us to ponder the mysteries of the universe and the terrors that come with exploring them. In many ways, Trace 2b is a metaphor for the darker sides of exploration and discovery. It helps us remember that the universe is vast and full of mysteries, and that not all of them are easy to understand or comforting. The darkness of Trace 2b is both a physical reality and a psychological representation of the fear of the unknown, of what we might find, and of confronting something. Trace 2b draws on this deep-seated association by providing a concrete example of a world that is genuinely dark, both physically and in a way that challenges our perception of what is normal and safe. It serves as a reminder that the cosmos is not simply filled with light, but also with forces that are beyond our comprehension, such as the unknown, danger, and ancient myths. Earth is a place of light and warmth, but is also home to cold, dark, and terrifying places. Despite the terror that such places can inspire, we can't help but be amazed by Trace 2b, which serves as a reminder that the cosmos is full of extremes, some of which are as fascinating as they are unsettling. The existence of a planet like Trace challenges our current understanding and makes us face the fact that the universe is far stranger and more complicated than we often give it credit for. A planet so far from its star that it is permanently frozen in winter was discovered in 2005. It orbits a star about 21,000 light-years away in the constellation Sagittarius. The discovery was a shock to the scientific community, but it pushes us to broaden our horizons, embrace the unknown, and accept that not all discoveries will be reassuring or easy to understand. Astronomers were able to detect Ogle, a planet so far from Earth that its gravity bends the light of a distant star as it passes in front of it, through a technique called gravitational microlensing. Ogle is often called a super-Earth, but it is otherwise very different from our own planet. Its mass is approximately 5 times that of Earth, making it larger, but not massive enough to be called a gas giant. What really sets this planet unique, though, is its location and the conditions that result from it. Ogle is located far from its parent star, far beyond the habitable zone where liquid water could exist. Instead, it resides in a region of space where temperatures drop to extreme lows, making it one of the coldest exoplanets known. The temperature on Ogle is, on this world where the cold is so profound and all-encompassing that it defines the planet's very essence. The enormous distance between Ogle and its star means that the surface of the planet would be a frozen wasteland with temperatures that are difficult to fully comprehend, hovering around minus 220 degrees Celsius. At these temperatures, even the most robust molecules would have trouble moving and the atmosphere would have frozen solid. Ogle lives in perpetual twilight, with its star appearing as little more than a distant dim point of light in the sky. The planet is bathed in darkness, with its surface illuminated only by the feeble light of its distant sun and the occasional glimmer of faraway stars. The extreme cold of Ogle raises intriguing questions about the star size and composition. Imagine a planet with extremely low temperatures. What kind of landscape could it have? Endless ice plains stretching out in every direction, perhaps, or craggy frozen mountains and deep ice valleys. Because of the lack of warmth, any atmosphere or water that may have once existed would be solidified, leaving behind a surface covered in thick layers of ice. The idea of a frozen giant like oil could also be present. The discovery of Ogle further complicates our understanding of planetary formation and evolution. How does a planet end up in such a low-temperature region of space, so far from its star? Did it form in such a far orbit, or was it pushed outward by gravitational interactions with other planets or stars? These questions underscore the variability and complexity of planetary systems throughout the universe, and they remind us that not every planet is like the ones in our solar system. It begs the question, could there be life in the deep cold of Ojal? Maybe in the form of microorganisms that have evolved to survive in extreme conditions. Although Earth's temperatures appear too low to support life as we know it, the cosmos is full of surprises, and life has shown to be remarkably adaptable in a wide range of environments. Even though this seems implausible, it's a question that pushes the boundaries of what's possible. The frigid surface of Ojal, illuminated by a faint, faraway star, creates an atmosphere of loneliness and emptiness. This is a planet on the cusp of what is theoretically possible, a world where warmth and life seem almost foreign. Visiting this planet compels us to face the boundaries of our understanding and our imagination as we attempt to conceptualize a reality so unlike our own. In spite of its harsh conditions, Ojal is a planet that is just as much a part of the cosmos as Earth. It shares our solar system, our laws of physics, and the forces of nature. The discovery of Ojal broadens our horizons by demonstrating that planets can exist in places we would never expect them to, and can even thrive in environments that appear completely alien. Iomelis, the uninhabitable planet, forces us to reevaluate our assumptions about the nature of planets and our place in the universe. As we consider the vast array of celestial bodies, we are struck by the sheer variety of life in the universe. Among these celestial bodies is HD 209458b, the first exoplanet to be seen transiting the face of its star, also known as Osiris. Located approximately 150 light-years away in the Pegasus constellation, Osiris is a gas giant that is larger than Jupiter and orbits its star very closely. Because of its extreme characteristics, astronomers have made Osiris a central object of their study. The original method for discovering Osiris, the radial velocity profile, was based on the detection of its gravitational influence on its parent star. Astronomers first noticed Osiris's transit in 1999, which allowed them to collect unique data about the planet. For the first time, they could see the star's light dimming as the planet passed in front of it, which allowed them to infer the planet's size, mass, and even the composition of its atmosphere. This was a huge breakthrough in velocity technique. Osiris orbits its star at a. Osiris's atmosphere is so bloated that the planet's diameter is about 35% larger than Jupiter's, despite having only about 70% of Jupiter's mass. Since it is in such close orbit, the planet experiences extreme conditions with temperatures soaring to around 1,000 degrees Celsius. The planet's rapid rotation takes little more than 3 days. Additionally, the planet's closeness to its star causes. One of the most remarkable findings from studying Osiris's transit was the process of atmospheric escape, which means that the planet's upper layers of atmosphere are heating up due to the star's intense radiation. This means that exoplanets, like the planets in our solar system, could have dynamic atmospheres that are affected by their environments. Therefore, studying Osiris was essential in confirming the existence of atmospheres. Before the discovery of Osiris, the concept of observing and studying an exoplanet's atmosphere was only a theoretical possibility. However, the transit of Osiris proved that not only could we detect such faraway atmospheres, but we could also start studying their composition and behavior in depth using spectroscopic techniques. Astronomers were able to detect signs of hydrogen, oxygen, carbon, and sodium, among other elements. This was a huge breakthrough in our understanding of exoplanets. The discovery of water vapor in Osiris's atmosphere was one of the most exciting results of the study. It was the first time that the composition of an exoplanet's atmosphere had been directly observed, which opened up a new field of study in astronomy, where scientists could compare the atmospheres of different exoplanets to find similarities and differences that might reveal more about the formation and evolution of these distant worlds. Are very high, which rules out the possibility of liquid water. However, the presence of water vapor in the planet's atmosphere raised the intriguing prospect that other exoplanets, especially those in cooler orbits, may also contain water, leading to potentially more favorable conditions for life. The significance of Osiris goes beyond its atmosphere, though. As the first transiting exoplanet, it served as a model for future investigations into other. One of the most important ways to discover and characterize exoplanets is through transit observations. Since Osiris, astronomers have identified thousands of planets, each with its own unique characteristics. The techniques developed to observe and analyze Osiris have been applied to hundreds of other exoplanets, allowing astronomers to build a detailed understanding of the diversity of planets in our galaxy. Osiris also helped to confirm that many of the exoplanets we observe, especially those close to their stars. These findings have expanded our understanding of how planets interact with their stars and the potential long-term evolution of planetary atmospheres. The discovery and study of Osiris had a profound impact on the field of exoplanet research, showing that planets can be found. The planet's bloated atmosphere and mass loss over time are direct consequences of its close orbit, highlighting the dynamic and sometimes violent nature of planetary systems. Osiris, as it is often known, is a space telescope that allows us to study planets beyond our solar system. By studying their atmospheres and physical properties in detail, we have developed increasingly sophisticated techniques for studying exoplanets. These techniques have brought us closer to answering fundamental questions about the nature of planets and the potential for life elsewhere in the universe. This gas giant, with its bloated atmosphere and slow mass loss, has taught us that the universe is full of planets that are as diverse as they are numerous. It has shown us that every planet has a story to tell, a story that can reveal more about the environment, the forces that shape them, and the moment when we began to move beyond just discovering exoplanets to truly studying them. 186F, an Earth-sized planet in the habitable zone, has captivated scientists and the public with its discovery in 2014 as part of NASA's Kepler Space Telescope mission to find Earth-like planets orbiting other stars. This discovery marked a monumental step forward in our search for planets similar to our own, as it was an important milestone in the ongoing search for life beyond Earth. Planet 186F orbits a star that is significantly smaller and cooler than our Sun. It is the first Earth-sized planet discovered within the habitable zone of its star, a region often called the Goldilocks zone because it is just the right temperature for water to remain a liquid state, assuming the planet has the right kind of atmosphere. The significance of this discovery cannot be overstated, as it brought us closer than ever before to discovering a world that could potentially harbor life. Red dwarfs like Kepler 186F receive less energy from their star than Earth does because they are about half the size and mass of the Sun. This causes them to emit less light, which means that the planet is probably cooler than Earth. However, the precise temperature of Kepler 186F is still uncertain due to its thick atmosphere, which could trap enough heat from gases like carbon dioxide to keep the planet at a relatively constant temperature. We have not yet confirmed the presence of water, an atmosphere, or any other indicators of life on Kepler 186F, but the planet's location within the habitable zone makes it one of the most promising candidates we have discovered thus far. If Kepler 186F does, in fact, have a stable atmosphere and liquid water, it could be home to a diverse range of life forms, from simple microorganisms to more complex ones, organisms depending on the environmental conditions. The possibilities are endless and inspire our imagination as we imagine what life could be like on this planet, which is similar to Earth in many ways. Kepler 186F is slightly bigger than Earth, with a radius about 10% greater than our own. This small size difference suggests that Kepler 186F has a strong gravitational pull, which could help retain an atmosphere over billions of years. Kepler 186F also has a significant orbit around its star. Kepler 186FF is a planet that orbits a cooler star and receives just the right amount of energy to stay within the habitable zone or just outside. One challenge with studying Kepler 186FF is its distance from Earth, which is 500 light-years away. Even the most powerful telescopes have trouble providing detailed information about the surface conditions or the planet's atmosphere. Although Kepler-186f receives less energy than Earth, it is still within a range that might allow for life, so scientists are re-evaluating the criteria for habitability. They can learn a lot about the planet's atmosphere composition through transmission spectroscopy, which studies the light from the planet's star as it passes through the planet's atmosphere during a transit. Kepler-186f is a reminder that life might exist in places that are very different from Earth, but still within the bounds of what is physically possible. Its significance extends beyond its potential for habitability, as its discovery has helped to illuminate the possibility that other planets, previously overlooked due to their cold temperatures, could also be habitable under the right conditions. Prove that planets the size of Earth are not uncommon in the galaxy, and that many of them may be located in the habitable zones of their stars. This finding has significant implications for our quest to discover extrasolar life. Since a high probability of discovering a planet that harbors life implies that the circumstances that gave rise to life on Earth may not be unique, and that there may be numerous other worlds where life has taken root. We are now entering a new era in the study of exoplanets, and Kepler-186f is a prime example of that. Not only are we finding planets, but planets that may be very similar to Earth have also been discovered. This has opened the door for future missions like the James Webb Space Telescope, which will provide even more detailed observations of exoplanets and their atmospheres. Ultimately, these missions will help us answer one of the most profound questions in science. Are we alone in the universe? While there is still a lot we don't know about Kepler-186f, its discovery has sparked hope and curiosity. It shows us that the universe is huge and full of possibilities, and that maybe there are other planets out there that could be habitable one day. Kepler-186f is a symbol of the progress we've made in our quest to find other worlds and of the exciting discoveries that are yet to come. HD 437G, also known as HDG, is an intriguing exoplanet in the habitable Z-zone. It is a super-R, a type of. Discovered in 2012, this planet, which is larger than Earth but smaller than gas giants like Neptune and Uranus, is located approximately 42 light-years from Earth in the constellation Pictor. It has become a focal point in the continuing search for possible habitable worlds beyond our solar system, as it orbits its star within the habitable zone, a region where conditions might allow for liquid water to exist on its surface. HD 4307 is a Kuiper dwarf star that is smaller and cooler than our Sun. Its planets receive enough energy from the star to form a habitable zone, where temperatures could be suitable for liquid water, a crucial component for life. HD 4307 is located within this zone, making it an attractive candidate for extraterrestrial life searches. One distinguishing feature of HD 4307 is its size, with a mass at least 7 times that of Earth. This makes it significantly larger than Earth and classifies it as. HDG is part of a multi-planet system with at least 6 known planets orbiting the same star. This system is relatively close to Earth in its orbit, which means that the planet's atmosphere and surface conditions could be affected by its stronger gravitational pull. Additionally, the planet's larger size suggests that it could have a thicker atmosphere, which could provide better insulation and protection from harmful cosmic radiation. A more stable environment for potential life forms could result from this. At a mere 42 light-years from Earth, HDG is incredibly close to Earth, making it an ideal candidate for future telescope observations of the planet's atmosphere. The fact that HDG is part of a multiplet system also begs the question of how planets in such systems interact with one another in their star. Scientists are especially intrigued by HDG because of the possibility that it could support liquid water. HDG is in the habitable zone, which means that, under ideal circumstances, liquid water could exist on its surface. This is significant because the presence of liquid water is a major factor in a planet's habitability. It is a solvent, after all, and it also plays a significant role in regulating a planet's temperature and supporting intricate ecosystems. Exactly what this means for HDG is still up for debate, though, and much depends on the makeup and thickness of the planet's atmosphere. Whether HDG's atmosphere is thick enough to trap enough heat to keep liquid water on the surface, Regardless of how much cooler the star is than the sun, or whether it's too thin, the planet could be too cold for liquid water, even though it's in the habitable zone, all depending on the composition of the atmosphere. Whether HDEG has a stable climate and can support life for extended periods depends on the composition of the atmosphere. The discovery of HDEG expands our knowledge of planetary systems, and HDEG's orbit around a star that is cooler and less massive than the Sun shows that life-supporting planets might not be limited to systems like our own, but could be found around a wide variety of stars. It also suggests that there may be many more such planets waiting to be discovered, which adds to the potential for life in the universe. Additionally, HDEG represents a new frontier. Exoplanet research has recently seen a surge in interest in studying super-Earths, especially those in the habitable zones of their stars. These planets hold immense potential to teach us about the galactic variety of planetary environments and the conditions needed for life. By studying HDEG and similar worlds, we can better plan future space missions to find extraterrestrial life. Additionally, besides its scientific significance, the discovery of HDEG has captivated both the general public and the scientific community. The concept of a planet, Earth-like but significantly larger, orbiting a distant star system is fascinating and motivating. It makes us wonder what life might be like on such a world, and what it would take to find signs of life on a planet so different from our own. Ultimately, the discovery of HDEG serves as a reminder that the universe is expansive and teeming with potential, and that we should never stop exploring. We are only at the beginning of our search for life beyond Earth. Future missions, like the one slated for the James Webb Space Telescope, will collect more detailed information about this intriguing planet, which could help us answer important questions about its ability to support life. Spectroscopy and direct imaging are two observational techniques that will likely be used in the continued study of HDEG. As our knowledge of exoplanets grows, we may one day be able to tell if HDEG is a habitable planet or simply another example of the vast variety of planets in the universe. HDEG serves as a reminder of how far we've come in our understanding of exoplanets and the possibility of life beyond Earth. It's a tribute to the ability to observe and discover, and it shows that there are many mysteries yet to be solved. HD 106906b, a planetary outlier known as HDB, is situated approximately 336 light-years from Earth in the constellation Crux. This exoplanet is extraordinary not only because of its massive size, but also because of the great distance it orbits its host star. Its orbit is both extremely unusual and fascinating to scientists, as it challenges our understanding of planet formation and evolution in ways that many of our conventional theories fail to explain. As a planet so far from its star, 650 astronomical units, AU, away, in a region of space where the star's gravitational influence is relatively weak compared to our own solar system, HDB has long baffled scientists and sparked intriguing theories about the mechanisms that cause such distant orbits. The discovery of HDB occurred in 2013, and since then, the object has been an enigma. The discovery of HDB has prompted scientists to re-evaluate the processes by which planets can form and reach such faraway orbits. Not only is it incredibly far away, but it is also massive, with a mass 11 times that of Jupiter. This makes it one of the most massive exoplanets known. Its size and mass indicate that it is a gas giant, mainly composed of hydrogen and helium, similar to Jupiter and Saturn, our solar system, but its position and orbit distinguish it from these well-known giants. The broad orbit of HDB casts doubt on the conventional wisdom about how planets form. According to these models, planets normally develop near their stars, in the protoplanetary disk, where the resources necessary to construct them are plentiful. However, HDB's faraway orbit implies that it may have formed via an alternative process, or that it has migrated considerably since formation. One theory is that HDB formed near its star but was ejected into its present orbit as a result of interactions with other large objects in the system. like a big planet or a passing star. This process, called gravitational scattering, could explain how the planet got so far from its star. The problem with this theory is that it would produce an extremely eccentric orbit, unlike HDB's seemingly circular orbit. Another theory suggests that HDB may have formed independently of its star, similar to brown dwarfs or low-mass stars. In this case, the planet could have formed when a separate cloud of gas and dust collapsed, with only a tenuous connection to the star system. In this view, HDB would be less of a planet than a failed star, a substellar object that never gained enough mass to trigger nuclear fusion. Stand in for both planets and brown dwarf objects, blurring the boundary between the two types of celestial bodies. HDB's peculiarities have piqued the interest of scientists worldwide, who are studying it to learn more about the formation and evolution of planetary systems. HDB's stability and longevity in such faraway orbits over time, as well as its interactions with other possible further perturbations to HDB's orbit from stars or the galactic environment could cause even more drastic shifts in its relative position to its host star. The discovery of HDB has made scientists think about what this could mean for other solar systems, including our own. After all, if such massive, faraway planets can exist in other systems, it could mean that similar objects exist in our solar system as well, outside of the Kuiper Belt and the known dwarf planets like Pluto. Meanwhile, the hunt for Planet 9 continues. Discoveries like HDB show that massive, faraway planets can exist, which has sparked speculation about other hypothetical large planets in our solar system. Exploring HDB and similar worlds has broadened our understanding of the range of possibilities for planetary systems, and it has challenged the idea that planets need to fit neatly into the models we've developed based on our solar system. Demonstrates that planetary configurations can be created by the universe in ways we haven't yet conceived, and serves as a reminder that our knowledge of the universe is constantly changing and that new discoveries can challenge our current theories, while opening up new research avenues. Ever since its discovery, HDB has remained a study object, with astronomers employing various observational techniques to deduce its orbital composition. Next-generation space telescopes like the James Webb Space Telescope will be able to take even better pictures of this faraway planet, which could shed light on its formation and the mechanisms that control its peculiar orbit. This, in turn, could help us understand how other planetary systems formed, as well as how HDB got here. Kelt 9b, the hottest exoplanet known to science, is located at the exoplanet 9b, a gas giant located approximately 670 light-years from Earth in the constellation Cygnus Kelt, has surface temperatures exceeding 4,000 degrees Celsius, or 7,200 degrees Fahrenheit. This extreme heat places it in a state of extreme uncertainty regarding its habitability as a planet, and its discovery in 2017 cast doubt on our current understanding of planetary environments. Kelt 9b is in a class all its own, which makes it an intriguing study subject for planetary conditions. It orbits a star called Kelt 9, which is a massive star that is both hotter and larger than our Sun. The planet is incredibly close to its star, with an orbital period of just 15 days. This makes it much closer to its star than Mercury is to the Sun. As a result of its intense radiation, Kelt 9b's temperatures reach some of the highest levels ever recorded. The conditions on Kelt 9b are unparalleled in our solar system. The planet's atmosphere, which is primarily composed of hydrogen and helium, is heated to such extreme temperatures that the molecules within it are thermally dissociated into individual atoms. This process is a result of the intense heat, which is comparable to the temperatures of some stars. That chemical bonds simply cannot hold together, leading to an extremely hot and chemically altered atmosphere on Kelt 99b. This environment resembles the outer layers of star rather than a typical planetary atmosphere. One of the most striking consequences of this extreme heat is the gradual removal of Kelt 9b's atmosphere, which is heated to the point where the outer layers start to. Departure into space results in a gas tail resembling a comet's tail. This tail is primarily composed of hydrogen, the lightest and most easily lost element in space. The planet's struggle to retain its atmosphere in the face of relentless radiation serves as a stark visual reminder of the powerful forces at work on K9b. The planet's extreme conditions have made it an important target for scientific study, especially in relation to. By studying the atmospheric loss and chemical changes on K9b, scientists can gain a better understanding of the processes that shape planetary atmospheres in extreme heat, which could be useful for studying the early atmospheres of rocky planets like Venus or Earth, as well as other hot Jupiters. Environment. One of the main concerns brought up by K9b is the expected lifetime of a planet in such a setting. The current rate of atmosphere loss indicates that K9b is slowly eroding its atmosphere, though the exact amount of material and duration of this process remain unknown. The planet's size and gravity assist in retaining a significant amount of its atmosphere, but the intense radiation from its star ensures that this process will persist for the duration of the planet's existence. Being in such a tight orbit, the slow loss of atmosphere can teach us a lot about how planets in extreme environments, especially those that circle around massive, hot stars, change over time. K9 offers a unique opportunity to study how planets interact with their stars outside of our solar system. The intense radiation from K9 causes the planet to be bombarded with high-energy particles all the time, which can impact. The study of K9b is contributing to a more comprehensive understanding of the interactions between planets and stars, especially in systems where the star's energy is dominant. The discovery of K9b has also encouraged scientists to consider the diversity of planetary systems in a broader light, which is crucial for comprehending the planet's atmosphere and magnetosphere, as well as other exoplanets that orbit close to their stars. K9b's harsh conditions demonstrate that planets can form and survive in a variety of environments, including those that appear inhospitable from Earth. This has important implications for our knowledge of planetary formation and evolution, as it shows that planets can exist in far more hostile environments than those in our solar system. Additionally, K9b serves as a reminder of the importance of the High-Degree Extremely Little Telescope KELT survey, an initiative to discover exoplanets in transit around bright stars, was instrumental in the discovery of K9b. Precise measurements of the planet's transit across its star revealed the planet's extreme conditions, highlighting the need for ongoing investment in telescopes and observational missions that can detect. In particular, scientists are interested in exoplanets that live in unusual or harsh environments, so they can learn more about K9b's atmosphere, how it interacts with its star, and what happens to extreme worlds like this in the long run. The information scientists learn from studying K9b will add to what is already known about exoplanets, which will improve our understanding of how planets form and evolve and the kinds of extreme environments they can inhabit. In terms of future research, K9b is sure to remain a focal point, especially with the advent of new telescopes and instruments that can capture even finer details of its atmosphere and its interactions with its star. The extreme conditions on K9b make it an intriguing object of study, and the insights obtained from studying it will undoubtedly expand our understanding of the universe and the limits of planetary science. K9b demonstrates the incredible power of scientific discovery, revealing that even in the harshest environments, there is a wealth of untapped knowledge waiting to be uncovered. If you like this video, please subscribe. Thank you for watching all the way to the end.